Figure capital A dot 1 concave and convex functions. Some functions are convex, some concave, and some neither. A. This function is concave because the straight line drawn between any 2 points never goes above the curve. B. This function is convex because a line drawn between 2 points never goes below the curve. C. This function violates both of these conditions and thus is neither convex nor concave. Equation capital A dot 1 is an extension of our never below the line test. If we let theta vary between 0 and 1, we can trace out all the values of the function f evaluated at points in capital A on the left hand side of the inequality, while varying theta on the right hand side of the expression traces out a line segment connecting the function f evaluated at open parentheses x comma y close parentheses and at open parentheses x prime comma y prime close parentheses. Thus, this expression says that the function lies above the connecting line. Sometimes a distinction is drawn between a function that is weakly concave or strictly concave. A weakly concave function f satisfies the requirement in equation capital A dot 1, while a strictly concave function satisfies a replacement condition. F open parentheses theta times x plus open bracket 1 minus theta close bracket times x prime comma theta times y plus open bracket 1 minus theta close bracket times y prime close parentheses is greater than theta times f open parentheses x comma y close parentheses plus open bracket 1 minus theta close bracket times f open parentheses x prime comma y prime close parentheses. A function is convex over a region capital A if the opposite of the concavity condition holds. That is, the function never goes above a line connecting points on the function, as panel B of figure capital A dot 1 illustrates. The mathematical requirement is the same as the requirement for concavity with the inequality reversed. The function f is weakly convex over capital A if for any value of theta such that 0 is less than theta and theta is less than 1, and for any open parentheses x comma y close parentheses and open parentheses x prime comma y prime close parentheses in capital A. F open parentheses theta times x plus open bracket 1 minus theta close bracket times x prime comma theta times y plus open bracket 1 minus theta close bracket times y prime close parentheses is less than or equal to theta times f open parentheses x comma y close parentheses plus theta plus open bracket 1 minus theta close bracket f open parentheses x prime comma y prime close parentheses. The function is strictly convex if this expression holds with a strict inequality. The function f of x equals x squared is strictly convex. To demonstrate this convexity, we pick any 2 points on the real line x and x prime and check that f of theta times x plus open bracket 1 minus theta close bracket times x prime is less than theta times f of x plus open bracket 1 minus theta close bracket times f of x prime holds for this function. We substitute the actual function into this expression, open parentheses, theta times x plus open bracket 1 minus theta close bracket times x prime close parentheses squared is less than theta times x squared plus open bracket 1 minus theta close bracket times open parentheses x prime close parentheses squared, or theta squared times x squared plus open bracket 1 minus theta close bracket squared open parentheses x prime close parentheses squared plus 2 theta open bracket 1 minus theta close bracket x times x prime is less than theta x squared plus open bracket 1 minus theta close bracket open parentheses x prime close parentheses squared. Rearranging terms, theta open bracket 1 minus theta close bracket x squared plus theta open bracket 1 minus theta close bracket open parentheses x prime close parentheses squared minus 2 theta open bracket 1 minus theta close bracket x times x prime is greater than 0, or x squared plus open parentheses x prime close parentheses squared minus 2 times x prime equals open parentheses x minus x prime close parentheses squared is greater than 0. Thus, this function is strictly convex. In panel C of figure capital A dot 1, the function x cubed is not concave or convex over the domain of real numbers. It is concave over the negative real numbers and convex over the positive real numbers. Finally, the Cobb-Douglas function f of capital K and capital L equals capital A, capital L to the power alpha, capital K to the power beta, where capital L and capital K are non-negative real numbers. It is concave if alpha plus beta is less than or equal to 1.